Good afternoon, Professor. I am recording assignment three, the uh, the hash function, hash table example. I have three files here. Uh, yes, entry file, uh, causing an executable condition. Uh, with our header file and our source file. It is a type of source file. Yes, I'm incorrect. I am trying to learn all the jargon and trying to implement them into because they weave in and out of each other depending on how the context is used. So I'm just trying to make sure I learn how to use all this nomenclature because like these objects, they're also called classes and they're parent classes and all these things. Uh, subclass. It's a sibling class. It's like, geez, so many ways to name everything and how things work with each other. So I'm just trying to keep reading and refine my communication because like right here, all you have is my cursor when I show, demonstrate and go through these examples. So speaking on them is really important. I think I mean anybody should understand that. So yeah, without further ado, I'm gonna continue here um, and share my program. Uh, Here's our header file with with our declarations, our headers for the libraries. I included a template to run this hash table, uh, named a hash function. This class here just encapsulated this the hash table, the pointer private. Have this recursive helper function to that is gonna have other functions passed to it, two overloaded functions. Here's our hash function constructor with two overloads, one overload. Here's our first method for that to create the hash table. And here's our getter function and our deconstructor. So and everything goes in order. Uh, Here we have our constructor. Here's our recursive function, and here's our first method, our overloaded method, our getter, and our deconstructor. And here's this instantiation that we need to do since we are taking this template class and splitting it into multiple files. Otherwise, it wasn't working for me. Um, it'll be declared if it just causes a jam, as I'm sure you know. And I have this example here to demonstrate how the recursive function works. Uh, uh, if we're to use this ABC, we're going to keep it easy. Uh, this ABC, uh, any string we put in, the function is going to grab the character, the first character, to begin with, and it's gonna use zero index. It's gonna call it zero index, and it's gonna plug it in into geez, I'll just use this one down here into this formula that I have above in the function. So the current hash times 31. I'm using 31 for to multiply as a prime number because that seems to be uh, the common used one is for many reasons to keep duplicates, collisions out and stuff like that. Let me see. Have it in my notes. Um, Now, 31 is a good prime number to often use for hashing because it distributes values more evenly and reduces collisions. And I use 1,000 modulo to ensure that the hash value stays small and manageable. It avoids overflow, keeps the final hash between 0 and 99 also. So, also the previous, yeah, just press, yeah. Anyways, uh, so it goes 0 and then it goes to 1. Now that now that we have A, we plug in A, the American Standard Code for Information Interchange. Value for A is 97. So we plug that in and so we plug that in the current hash times 31 uh plus the 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 ASCII will give divided by modulo 1,000 will give us the value of 97. And so we do that again. We plug that in for B. Uh, this is where we have our ASCII times 31 plus the index. I'm reading it wrong. The current hash. The current hash being the character. Um, that value is going to go right here. That's coming from the standard code, uh, and that gets multiplied by 31, and then the value of the text value gets plugged in here. No, I'm wrong again. So the ASC gets plugged in here. Uh, and that's how we come up with 98 because it's B. B is in position one of the arrays, and that gets plugged in here. And so 97, being the current hash, 97 times 31 plus 98 divided by 1,000 modulo will give us 105. And so right here, as you can see, position two will go to 105, and the last one will be 354. So once we reach, say we did ABC, once we reach to the end, then we reach the base case. So here, once index is greater or equal to text length. So in that case, the text length was ABC. We got to the third one. We got to C position, and that reaches our base case of the string, and then we start we go in reverse order. We unwind and we propagate all the way back down to the initial state of call, to the initial index. So we propagate back down. The value that has been generated, that has been hashed, gets propagated back down, and that gets returned to the caller. And in that case, main, and from that point, now that it gets returned here, it can continue on to this output with a message to the user, giving them, returning them the value, the get hash. Here we return them the value that has been hashed out. And so that'll take care of the first. That's how the function works. And setting it up here, we we uh, we declared our variables. We have our input, our and we have created our object for named it hasher. So here we call our hash input, which will be for the first one. We are using we're able to convert. It calls it calls this one right here, and it gets converted regardless of what we input. It gets converted to text, to an integer. It gets converted from string to a number, and then we call it up here. We call this we call this function to call our recursion, our recursion function, and it'll keep running again until we bottom out, and then it rewinds. But that takes place in our first one, and once we get a return, uh, we get the value, and then it prompts the user for to input an integer, and so we declare variables. We allow the input, and we return and we call this hash number this hash number once again comes down, runs up here, runs through, calls this recursion, this loop, this if statement, and until this logic is satisfied right here, to this condition, index is greater to or equal than, and then following uh, following that, yeah, it we have our deconstructor for better input handling, uh, and that's the end of it. Return zero. Uh, so I will run the program, enter hash. So we will do ABC 354 as our example. Enter introduce the hash. What'd you do? 1, 2, 3, 690, and any key to close. And there it is. Thank you, Professor. Appreciate your time. I have more assignments coming.